Hi, I'm Dave Robinson, Chief Data Scientist at DataCamp, and today I'm going to be recording a screencast of myself analyzing some data that I've never seen before. So this is the fourth screencast that I've done, and it's all been from the Tidy Tuesday series of data sets, where every Tuesday the R for Data Science learning community releases a new data set, and I analyze it to discover something about it. So for 1 hour today, we're going to be taking a look at the U.S. wind farm locations data set. I don't know anything about that besides seeing just that title. All right, so I'm going to click in, and we're going to be analyzing it in our studio in a new R Markdown file. All right, so let's click in. Some questions: how do new installations compare to older turbines? Which states' regions have the most wind farms? What's the spread of them over time? Where's the most missing data? There's a lot of missing data, but still an interesting data set. Maybe later we'll check out the interactive map. I'm not that good at interactive mapping, but maybe I can try building one with perhaps the leaflet package. We'll see where we get today. And let's see. Okay, there's going to be some missing data where things like -9999 means missing data. And here's all the fields we work with. Wow, this is more fields than I'm accustomed to in R for Data Science. This is, I think, this might be the most columns I've seen in a data set yet. It's not too many, but it's worth discovering. All right, it's all in that CSV file. Oh wow, there's even more data sets we could bring in if we want. Okay. Lots, and here it shows how many are non-missing, usually about 50 to 60,000. A few of them have a lot of missing data. Okay, and that's really interesting. Let's get the data into R. What I do is I click here, click View Raw, and grab the URL. I don't even need to wait for the file to load, because I do library tidyverse, and then I do read CSV, and then a link, and we call it US Wind, and this is our data set. If I put it into the capital V view function, I get to view it a little bit like a spreadsheet and take a look through. All right, so we have some that are categories like state and county. We have some that I'm going to assume this is a zip code, but why is it named FIPS? I don't know what that stands for. State and county. Oh, I think this is like a 5-digit identification code. But if it's not a zip code, yeah, I'm not particularly familiar with that. That's okay. Worth knowing. Then we have project name, the year it became operational, the number of turbines, its capacity. We're definitely drawing some maps here because I saw there it is, longitude and latitude. That's great. And mostly not missing. All right, and we have some characteristics of the turbine. So I guess capacity, height, diameter, area. Okay, so this is like the size of the wind power, or the size of the machine that they're using to collect wind power. Okay, this is really interesting. All right. We're going to... you might have noticed that the first thing I did with most data sets is I start counting categorical columns, where I would say, it is U.S. wind, and I'll say, let's count state. I'm really wondering what states have the most. Are they the big states like California and Texas, or are they Midwestern states? So we have Texas and California, the two biggest states, but also I'm pretty sure IA is Iowa, which is not a huge state, but it has looks like it has a lot of wind turbines. Just from glancing at this, I think it's centered in the Midwest and the West. Just from glancing at some of the top states and trying to recognize their postal codes. Okay. I'm going to return to states in a second. I'm interested in, are the project names duplicated? They are. Okay, so we have lots of things from Greenridge Power, lots of things from State Line Wind Project, things from Mesa Wind Farm. We have lots of individual projects that each have loads and loads of turbines. All right, that's really worth knowing. We might be able to we can do something with that data. if we wanted to right now, we could clean some of these attributes. I'm not going to look at that yet because I'm really interested in space. We have a longitude and a latitude. Let's do something with it. Let's plot it. So I have longitude is on the x-axis. It's nice they actually said x long and y lat to help remind us. And we can actually just do a scatter plot of it if we want. Like, bingo, we just have scatter plot of, here it's popping up. How many rows does this have? 58,000. I would have expected to be a little bit faster. Okay. What we show here is, what we have is, this is one dot for every turbine that's, is it one row per turbine? It's one row for each wind turbine. It's in the United States, but we actually notice, I'm going to guess this is a bit of Hawaii that stretches off across the international date line, so it has a maximum X long instead of a minimum. I'm actually going to filter that out because we could include it, but what a hassle. If I just say less than 100, it's going to look a bit more like the United States. Okay. There's a theme. There's actually one thing we do whenever we're plotting a map, we want coord map from ggplot2. Oh, it looks like I need a package it doesn't have. So I'm going to install map project. Coord map is going to keep these dimensions clean. We haven't looked at map data yet in any of the Tidy Tuesdays, so I'm excited to walk through this process. This keeps the dimensions closer to what they should be in a longitude and latitude. You even notice they're not evenly spaced. Okay, now that I've done coord map, I do not know what. Oh, this must be I guess something in the Caribbean. Is this Puerto Rico? I don't know geography very well. This could be Puerto Rico or something else in the Caribbean. It's possible that the dot way over there was not Hawaii, but in fact Guam. Again, I'm not great at geography, so I could be mixing all of these up. But I've done a coord map, and I'm going to throw in one more thing: a theme void, blank out those axes. So it looks a little like a map in that we have the continental U.S., Alaska, Hawaii. Later, we could filter these to just be continental. I think it's going to be hard to include everything, Alaska and Hawaii, in every graph we make. For now, I'm going to leave them in. Check this out. This does not look like a map yet. It does it because it doesn't have borders. ggplot2 is something really handy, where if I say borders, I believe it's called state, it's going to throw those borders of the U.S. states onto the map. So here's where we actually see the continental U.S. Now the map's starting to come together a little bit. And one of the things that it's definitely making me notice is we don't have Alaska and Hawaii in this one. Maybe we'll come back to them later. Maybe we never will. Let's look just at the continental United States. Continental U.S. So that's 48 states. Plus the District of Columbia. And when we're making a map, let's look only at those states. That'll probably let us avoid our filter too. When I counted T state, I wonder, Hawaii and Alaska must have been in this. Aha, and there's Guam. I believe GU is Guam. And, if I said, I wonder, do I see anything for PR Puerto Rico? I'm not sure. What I can do is try filtering for the T state, not T state in. There are other ways we could try doing this, get the state names in, but I'm going to say not in Alaska, AK, which I happen to know is AK. Hawaii, I believe, is HI. Oh, Guam is, GU, not GM. Again, my geography is not amazing, so apologies if I'm mixing up some states or some countries or some territories. Yeah, and I'm going to guess, perhaps, so this shows our distribution of wind turbines. It's much more limited to the continental U.S. I'm going to guess this is Puerto Rico. Let's find out. This is one of those early experimentation. Yeah, it looks like that was PR Puerto Rico. And All right, so right now we have, hey, a pretty interesting map of the of locations of wind turbines, and we looked at counts of states earlier, but this actually tells us a lot more in terms of, wow, there's really a cluster of wind turbines that are stretching across the middle of the country. Some in New England, almost none in the entire southeast of the United States, some in California, some in the Pacific Northwest, but really clustered around here. All right, that's we've learned something. That's interesting. We also have projects. We took a look at, I liked that we saw earlier that we had count the, where is it? Count, what do we call it? P name, project name. There are 1,500 projects. So I'm really interested, like Green Ridge Power, I wonder where that was in the country. What I'm going to do is after I filter, but before I plot it, I'm going to lump these categories. I'm going to say pname is FCT lump of pname, and I want just 6 categories plus other. And now all the other ones that aren't one of those 6 countries will get the name other, but I neglected to say color equals pname, and now I'm going to color this graph based on the project where it initiated. This was not what I was hoping for. We're seeing the ones that actually we can't find the individual projects because everything got covered up by other. I'm going to sort this. When you make a geom point, it ends up arranged where it plots the graphs first in the table, the earlier in the table first. So if I arrange by let me see. I'll have to arrange by the p name is not equal to other, because false comes before true. So if I arrange by p name is not equal to other, all the falses, all the others will actually come first, and that means all of our non-other graphs will be plotted last. So if I plot it that way, at least the others will end up on the bottom of the graph. All right, slightly more informative. What I'm noticing is now I can pick out a couple projects. Aha. So projects are really, really clustered, it looks like. Like I kind of was thinking, oh, maybe all of these would be in such and such project. But now I'm realizing maybe it's many turbines in like one field. Wow. Okay, so I shouldn't have been thinking of it as a project covering a range of area. Maybe every project should be just one dot. All right, so let's take a look at this. I'm going to turn this into US wind processed, where I do this filtering. And instead of counting the names, I'm going to group by the project name and summarize the number of turbines is N. So here's a project, 251 wind, that had 190 turbines. Now I'm realizing maybe we also want to group by the state. So T state. So now we can say 251 wind had 190 turbines, and they were in California. Now it is possible we're going to get the same project across multiple states. We don't know. Right now it's summarized by P name, so I'm curious how common that is. If I count again, some projects are across 2 states. This N now represents how many states was the project in. Wow, only a handful. Okay, here's what I'm going to do. I'm going to aggregate by both project and state, which means if a project falls across state lines, it'll end up with 2 dots here. I'm doing that because I'm concerned about maybe there's some cases where projects are very spread out. So I'm going to leave this group by both P name and T and the state that it's in. But now that I've done that, here's what I'm going to try. I'm going to take the centroid of every project. What do I mean by centroid? I mean the average longitude, the average latitude, so that each project just gets one dot. So I'm going to say x long equals mean of x long, and x and y lat equals mean of y lat. And now I've got a location for every project. Maybe the turbines are really spread out. Maybe they're really clustered together. And to just get a sense of how spread out are they, I'm actually going to say x lat is the standard deviation of xsd and ysd. I'm going to get the standard deviation in each direction. When there's only one turbine, this will be NA, but here there's not only one turbine. I made a mistake here. You can't summarize with a column, and then you can't summarize and then do something on it with the same name. I'm actually going to rename them because I don't need the X and the Y. I'm going to say lat SD. So ln is mean X long, lat is mean Y lat, ln SD is the standard deviation, lat SD. Okay, we're not going to have a standard deviation for ones that have only one turbine. That makes sense. This is how spread out the project is. So this is a project with 10 turbines that was really clustered close together. Pardon me. This one is as 190 turbines, but they're clustered close together. Low standard deviation in the X and Y. And here, this one had a high standard deviation for both the longitude and the latitude. The Iowa DG portfolio looks like it's probably spread out pretty well across Iowa. All right. So now we have a measure we have a centroid for them, a ln and lat, and I'm going to call it wind projects. So I'm going to take wind projects, and I'm going to use that as our I'm going to use that in our graph instead of using the one dot for every turbine. It's going to be a lot less data. And I change the name to ln and lat, and don't use color, but I am going to say size is the number of turbines. I want the big projects to pop out. Look at that. This is a much better graph, I think, than the previous one, because it shows one dot for each individual project, and we see some of the here's a really big project popping up in California. All right. That's really interesting. This is a solid graph. We probably want to get some color onto it. Okay. Let's take a look at getting color into this graph, and to do that, we need to decide what's an interesting thing to find out about this data. One that's very interesting to me is the year where it started. Project year. Oh, I love this. It's making me feel like maybe every project has just one year. That was what I was hoping. I'm going to quickly confirm that because it would be a bummer if some turbines of the project have one and some have another. What I do is if I say distinct P name and P year, and then count P name. This is me quickly checking the integrity of the data. Okay, some projects have multiple years. We have 1,400 projects. Man, a whole bunch of them have multiple years. Do they if they go across states? Probably. Now that I'm looking at it. Okay, I'm going to save my file. US wind. And then, how long did that take me? 18 minutes. All right. And I'm going to actually say what was the first year where it started. So I'm going to say year equals min of P year. While I'm at it, I'm really wondering, really there are 11 different years for this one project? If I say P name, I get a filter for the one anomalous case. Wow, arranged by project year. Look at that. We got a bunch in 1984, then some in 1986, and it goes all the way to 2016. Okay, that's worth knowing. I'm going to go with the first year. And now that I've done that, I can actually say, when in history have we had our we built these projects? Have these projects like 251 Wind or 6th Station Warning Squadron? When have these wind turbines started? And what I can say is, let's just histogram the year. Usually I'd use a line plot. Oops, missing data is negative 9,000 something. All right, here's where we start cleaning data. I'm going to say to replace this one and say that p year, that's our year, no, it's p year, is if else p year less than, I don't know, what year, what even is it? I'm just going to say less than negative 8,000. That's a pretty easy barrier because I don't even know if it's 999. Don't even have to check. Then make it NA. Otherwise, use P year. This way, I've just replaced some with NAs. And now if I histogram it, glad I did that. There we go. We have a handful of projects in the 80s, a bunch in 2000, and then it looks like most of the ones we have on record here are around 2010, 2012, years like this. Okay, that's pretty interesting. And I don't know about you, I'm really interested in the evolution of this over time. So what if I say size is turbines, but color is the year? So now I'm going to make this map and have color represent how old was the project, or at least when did the project start. We have some missing years. Those end up these gray ones. I'm going to say if they're missing for some projects but not others, I still want a value. It's probably not going to make much of a difference, but NARM equals true might get us a couple points back if we're missing one turbine for some reason. I see these are the oldest, and some of these are the newest projects. Okay, so 1980 with the dark points, these are the newest. I think I'm going to make an animation. I'm not 100% sure yet, but I might take a look at a bit and make it an animation. That might be what I do instead of making it an interactive graph. All right, so let's look at something though besides a graph for a moment. Let's look at back at the data and say, I'm really interested in at least a few of these extra fields. So let's see. All right, digital obstacles. I don't know what that really refers to. The county, the state, the project, the number of turbines. Oh, I just did this with a count. I don't know if that's project capacity. I wonder if that's different for different turbines within the same project. All right, so if I said count distinct P name and P cap, the capacity of the project, count P name sort equals true. A bunch of them have different values, like not that many. There's 1,400 projects. All right, more than 100 have two different values for project capacity across the same project. Yeah, again, I don't know quite what to make with of that data, but the this looks like, I'm going to guess MW is megawatts. But to me, anyway, that's an interesting question. Is like, what's the total wattage of this project? I wonder if I think if I see disagreeing values, I'm probably going to take the average. Let's take a look at one of these. P name filter. P name is McNeilius. And I'm going to do count P cap sort is true. All right, so we have varying capacities. It's supposed to be a capacity for the project. That's a little surprising to me. Do we have a capacity of the turbine? Okay, we do. We do. I'm going to use the total capacity of turbines instead of using the project capacity. I'm aggregating data already, and I don't know how they came up with this. I'm going to sum up the TCAPs. If these may disagree and I don't know what to do, then I might want to go back to the person that created this and point that out. But I'm going to start with the total capacity, and I'm going to say, let me see, turbines total capacity is the sum of TCAP. NARM equals true. And as soon as I realize that I have missing data, I want to say, do we have missing data in the turbine capacity? So I'm guessing turbine capacity is, so kilowatt, watt is a unit of power, amount of energy created per hour. So so it's like how much energy does it generate? Capacity might mean maximum. I'm not an electrical engineer or anything. All right, so I want to filter the negative 9999s. Yeah, basically I could say if it's less than 0, make it NA. It doesn't really make a difference. But I could say T cap equals if else T cap less than 0 NA T cap. And what I could say is, yes, sum of T cap. Okay, and then I get that's the total capacity for ones that aren't missing. Now, if I have I still have it, I'm not going to use, I might use state. I'm going to leave this ungrouped. Okay, now I've got my wind projects. And I've got year, and I've got the total capacity in kilowatts of the turbines in that in that project. So I'm actually interested in how has turbine capacity changed over time. I'm not going to make it a title actually. This would be the kinds of questions I might be interested in. I think it was one of the prompts. If I say wind projects. And our 1440 projects, and if I say let's actually group by year. No, I take it back. Let's make a scatter plot. Let's start with year and total capacity. I have a feeling we might need a log Y scale. I'm not entirely sure. Oh, that's really cool. What we see is back in the 80s, they had a limited total capacity, and that has increased over time. I might want to look at the either the average or the median capacity over time. I'm going to go ahead and group by year. I'm going to say median capacity. I might get back to that. So median capacity is the median of the total capacity. And instead of a scatter plot, I'm going to make a line graph. All right. This makes me realize that, yeah, the one project might drive a lot of the change in a year. All right, so it's this might be like a couple really large projects. I'm also going to include a column of projects equals n, and I'm going to actually take a quick look at that data, arrange it by year, view. Okay. One thing I notice is there are a bunch of years here where there are only a handful of projects. I don't want to believe these years too much. This third one was the median of just 2 values, which is all the same as the mean for those. 2013, we had missing data, it looks like, so we actually ended up with a 0. Because, yeah, now that I'm looking at it, I don't know that I do want to NARM is true on this sum, because if I'm missing the capacity of, I might be, yeah, I'm going to want to go ahead and miss that entire project. Wow, we're missing loads. Oh, if I take the median though, it needs to be NARM equals true. We'd always need to make choices when we're missing data. And here I'm going to say, aggregating within a project, missing data is contagious. Across projects, it's not. Okay. Oh, that's charming. We have an infinite year. Don't know what to do about that. But I'll start by, here we go. Okay, this is the median capacity. It's interesting. I don't think I want to look at the median. I think I want to look back at that scatter plot. I think this got more across. If I said every year, how big have been the capacity of your projects. Total capacity. This got a little bit more across to me. This is one option. I could try putting the y-axis on a log scale. I don't know how that's going to work out. I'm not really as crazy about this. It does make it look like it's going up over time, and I bet if I added a line that it is going up over time. Try not adding a line, but any kind of curve. A lowest curve. Don't love that. Like, not enough data back here. So yeah, I think maybe it was the right call to just show. Actually gonna quickly try this without a log scale. I hate all of these. Nope. All right. I'm going to stick to this one for now and say every dot is one project. And here's the total capacity of turbines in that project. We basically see all the big ones have been happening since, at least in this data set. Maybe there were other ones. But the big ones in this data set have been happening recently, since 2000. Okay. What about the capacity per turbine? That's an interesting one. So if I can actually say wind projects, and I can actually graph, because what's interesting to me is maybe they've just been getting bigger. What if I said the number of turbines? I bet, no, that hasn't been really growing. We had one really big one. If it's growing, it's hard to tell in this data. I think the increase might in fact be if I'm looking for total capacity per turbine, I could have used mean as well. Look at that. It's really been going up. This could be advances in wind technology. We could be saying that before 2000, there were turbines with more than 1,000 kilowatts, so more than a megawatt capacity, and now they're up to like 3 and 4. That's really, I don't know about you, but I'm pretty interested in that. That's cool. All right. What if I tried putting the capacity on this graph? So we have here sizes, turbines, color. Right now we have year to represent time. And what if I said the color is the total capacity? A lot of missing data in this one. So that's one of our really big problems. We have some of these biggest ones where we don't have. That's right. Within a project, if even one turbine was missing a capacity, I end up skipping it. I really wonder, those big projects, I don't love the missing data. Normally I would go about trying to visualize this in a slightly different way, where I tried doing, I don't love the dark blue to light blue. I like to switch it to like blue to red or something like that. Here, there's so much missing data on some of the ones I care most about. Also, I'm not just glancing at this not so clean plot. I'm not seeing the biggest pattern. Maybe it's bigger here than it is other places. Okay. I'm gonna move. I'm gonna move on without changing the scale. Let's look at another feature of the turbine. Number of turbines per project, the capacity. I don't know much. I don't think I'll be able to find out much about the manufacturer. The turbine model. I wonder how many models there are. If I take wind project. Oh, not the projects. I need to look at the original where the data is. U.S. wind process. And I count the model, key model. Not quite as many as I expected. 255 models of turbine. If I were an engineer, though, I'd be pretty interested in both in what are the most common models and what's the typical capacity of them. So, for example, I'm actually kind of interested. Do the many turbines of one particular model, do they all have similar specs? So, for example, here's our 8,500 turbines this is probably General Electric, some particular model of turbine. And if I view this, assuming it's not packed with missing data, I wonder what's its, not the project by turbine capacity. Hey, look at that. They're all 1,500. This might be a characteristic of the data that every model has particular capacity and all of these characteristics. What is an RSA? What is an RSA? Oh, here it is. The rotor swept area. Okay, I guess that's a measure of like the size of the turbine. And then we have total height, the diameter. hub height. Okay, so I have like size of the turbine, then the capacity. And I'm going to find out, do all models have just one capacity? So I'm gonna try this a little bit differently. I just want to understand, does the model contain everything I want to know about the particular values for a model? So if I group by the turbine model, I can summarize the how many distinct how many distinct T caps are there? How many distinct capacities are there? I can say n distinct of T cap, arranged by descending T cap. Some of them, missing, right. If the model is missing, some of them all the same capacity. How common are our missing ones? There are 255 models, and some of them have multiple capacities. So if I have Z40, for example, filter T model equals, I don't know, are you a wind engineer? I don't know what Z40 is, but I imagine that, go 6.05, that's a project capacity, pardon me. T cap, one of them was 1,000. Is this a mistake, or is this, I wouldn't be shocked if this were a mistake, because you're noticing everything else in this matches up exactly. The manufacturer, the model, the project capacity. This is in the same project. One of them, I guess this all came from imaging data. Let's take a quick look at the source of image used to visually verify turbine location. Okay, this one came from a different source. Maybe that means it joined in the capacity in a different data set. Okay, so that's one example. What if I looked at another one? What I'm trying to figure out is there a reason there are different characteristics for the same model? This one is, here we go. Same model, mostly the same turbine. If I sorted it, most of the same capacity. If I go all the way to the bottom, presumably, and some are 2,200, and we don't know the reason. Okay, so what I would probably do is take the average and just trust that. So if I wanted to say, what are the types of turbines one could build, I would probably take the data, summarize by, take the model, and take the average of the capacity and the other values. I could also take the median. Why don't I take the median? When there's cases where it's mostly one value but sometimes another, the median is going to be a little bit safer. I'm going to go ahead and say median. I don't just want T-cap. I want all of these. I want to know the T-cap, all these values, and I do not want the minus 999s. All right, so what I can do is actually say, I'm going to do one thing in the processing step to clean this data. I'm going to do a mutate at. Mutate at says everything that starts with, actually going to do it a bit differently. I take that back. I'm going to do a mutate if. I'm going to say if every column that is numeric, I'm going to apply the if-else function to. And in particular, I'm going to say, I should do it this way. If your if dot is equal to negative 9999, then replace with NA. Otherwise, use the dot. This was me doing this to every numeric column. So now if I ran that same line, now these are missing data. That's really good to know. All right. I'm going to now group by the T model and summarize at. And I'll summarize at the HHRD, all these characteristics that I totally understand. No, I don't. And for all of them, I'm going to take the median. Summarize at is great for I want to aggregate each of these columns. And I'm also going to say, Unfortunately, on these, I can't say how many turbines this is based on. It probably doesn't actually matter for turbine characteristics, but it would be nice to know the most popular. Here's a challenge of summarize at. It's great for do the same thing to many columns, but not if I want to add one extra column. I'm actually going to not use summarize at. I'm going to do this the old-fashioned way. Say median, THH, and I'm going to put this a couple of times. Copy paste. The thinking analysts, functional programming. RSA and TTLH. And now we can add the number of turbines is N. Now we know how common each of these turbines are. And yeah, so I say number of turbines, and I'm also going to say the number of projects. So that'll be N distinct on project name. It's going to be actually interesting to me to know, here's one with 6 turbines in this model, but they're all in the same project. And now if I arrange in descending order of how many distinct projects did you work in, what we see as missing, of course, we have some that we don't know the model, but we say 147 project use this turbine. And it's and here are the characteristics. The capacity, I did not include TCAP. I think that was my favorite one, median of TCAP. So now I can say, here's the capacity of this turbine. All right. Finally, this gives me one idea for comparing models, which is now that we have this data aggregated, this is like model efficacy. This is like, we can actually call this turbine models. We've aggregated this data by turbine. This could have been the raw data. They could have just said, here you go, here's some data on the efficiency of turbines. Bunch of missing values, but what if I said, how does capacity compare to the total height, TTLH? I can say TTLH, TCAP, geom point, and say, do bigger turbines tend to have higher capacity? TTLH, is it TTLH? TTLH? TTLH, good. Okay. Yeah, bigger turbine is better. So I would title this graph and I would say, when it comes to turbines, bigger is better. Cool. So the just bigger turbines have higher power. I could also create a graph. In this case, I really want X to say total height. I basically want to copy this exact thing and say turbine total height meters. These are some outliers. These are really big turbines. That are 200 meters tall. It's pretty tall. And then I'd say Y is turbine capacity kilowatts. I believe that's kilowatts. Okay. And I could do the same thing for the rotor swept area, the RSA. Turbine rotor swept area. And quickly check that's meters squared. Square meters. Even clearer. But notice, this is so interesting. It's like, it's perfectly linear. We could, if we were engineers, we'd get an exact formula for, given this rotor swept area, here's the capacity. But it breaks down for larger rotor swept areas. Maybe there's, and actually notice it's kind of lower than this line. Maybe there's particular inefficiencies in making too big a turbine and getting all the capacity out of it. That's interesting. It's also, actually, no, this makes sense to me. The area turns directly into power for a turbine. That feels plausible. All right. We could dive more into models and how they affect effectiveness, but that's really more for certainly for engineers. They would be interested in that. But let's go on to one interesting graph. I have about 15 minutes left. I want to make an animation. I'm looking at this graph. Where's my graph of change over time? Here it is. I'm going to do sizes, turbines, colors, year. Okay. this is a solid graph. It's certainly not terrible. But, 1 second. Yeah. This is a solid graph. But for saying, like, these are the old turbines, these are the new turbines. But what I want to do is actually say, let's turn this into an animation. Let's watch the spread of dots across across the continental U.S. So, animation. For animations, I use the GG Animate package. This package was originally my work. I can install the latest version. I'm not sure what version I have. But it's since been transferred to Thomas Pedersen, who has done an amazing job on this on GG Animate, and has really revamped the entire graphing system. So I'm actually not as familiar with using Thomas's version as I am with using my own. But the with the old version, but I can remind myself quickly. So I'm going to go do a little bit of looking up to remind myself how to create an animation. The great thing in general about GG Animate is that it's if you've got a graph, you're already most of the way there. So I'm going to, let's see. Ooh. Okay. These are, all right. So let's see. So this would be for if we have change over time. We sort of have change over time, but we really want new graphs. So we really want new years over time. All right. Let's see. It's still installing. So what I'm going to say, so really I want it to be cumulative. I'm trying to remember how to do that in GG Animate. So let's see. Okay. Let's find out. New data should appear. Old data should disappear. I wonder how. New data, old data. All right. Oops. I'm going to restart R. When you get one of those things, it usually means you want to, little messages, usually means you want to restart R. Okay. And then I quickly rerun the code that I had so far, including getting wind projects, which is what I'm graphing. Now, here's my wind projects. Okay. And one thing I think is that if I just say transition states, this is like the Hello World version, and if I say by year, I think we're going to have new points popping in and then disappearing over time. Let's find out how this works. It's been a while since I ran an animation, so it's a chance for me to embarrass myself. Library GG Animate. Let's find out if I am any good at this. Okay, I might need to turn down the frames per second. This one's going to take a while, and it's still our first variation. How do I turn down the frames? Oh, that's the old version. It's mine. Okay, I'm not quite up to speed on my animations, so I'm looking forward to finding out with you how I'm gonna make this graph work. Let's see how the first variation looks. I think what's going to happen is we're going to have ones appearing and disappearing. That's not good. Okay. Going back to my project. Luckily I'd saved. Back up to speed. All right, I'm going to quickly run a hello world. So if I'm debugging, what I do is I generally go to an existing graph, and I try creating it like an example one, and I ensure that works. So we sometimes call like a hello world. So this one should take 14 seconds. And the hope that I want to create is I really want to see the dots appear on the map over time. If I get a seg fault, that means no animations today. Nope, this one works. Yeah, look at that. So this is the example did work. Okay. The other possibility is all right, so I'll take a look at our wind projects. And what if I tried making the problem a lot easier? What if I said transition to what if I said take wind projects, filter not is in a year, and yeah. Also, what if I tried dropping the borders very briefly? And while I'm at it, I'll say I'll sample only 100 rows from it. This should be hopefully a faster graph. Oops, sample n is what I meant. Okay, I noticed the graph isn't faster, which makes me think I did something wrong. 3.2, oh, I'm starting to realize I don't need things to fade in and out. I just, which is what this is doing. This is doing individual frames. Let's figure out how to set frames per second. GG animate, FPS. I think there's an option for it. I just can't quite remember. FPS. This is an old version. Can be any combination. Here it is. So it calls the animate function. Oh, so it happens on rendering. Oh, look at that. That's not a great graph. But it did work. So what if I tried 1,000? What if I tried 1,000 points? So what's happening here is it's showing one frame for each new dot popping up. You're watching the enjoyable process of me figuring out how animations work and trying not to get another segmentation fault. So I'm going to remind myself, how do I set the interval? I guess I call animate instead of printing it. I guess animate has default arguments. And all right, I can probably try that out. So I can also say what kind of transition do I want. That actually might be easier because transition states ease AES. I actually want nothing in between the 2 years, but let's see. Okay, this was it's actually moving the points around, which I actually don't need it to do, but it does look kind of interesting. Okay, what I really wanted was to have, let's see, what kind of ease. What I want to do is have every point pop up only once. Okay, ease and ease. What kind of eases do I do? What I want is a low. I really don't want any points in between 2 years. It's just wasting time that I don't need for it. But I'm going to go ahead and try with all the data. Let's just see how this looks. Let's actually kill that. What I want to do is create a plot, animate the plot, P, and say n frames equals 20. That I think is how I make a faster plot. Here it is. So here's what's happening. We're seeing all the new ones pop up, but they're not cumulative. Nope, that would be doing that, except I noticed it's really stopping at some point. Oh, I said n frames. I wanted FPS. Frames per second. This is only looking at the first couple rows. Why is it still saying 3 FPS? And now I remind myself, what is in animate? Frame rate of the animation in frames per second. Number of frames to render. The duration. Okay. Yeah, I really thought that setting FPS to 1 would make a lower frame rate. Let's Let's find out. It's rendering. Aha, here it goes. So these are, I guess, new ones popping up in California. If I'm right, then we should start seeing the rest of the country pop up at some point. Would you believe him? Oh, there it goes. I think we'll see more once we get to 2000. And this reminds me that we can add, I think it's something like we add title. Ooh, look at that. And now it's more and more popping up. So now we have the new ones popping up in each year. But it's not cumulative. Aha. We're getting into the 2000s now, I think. I was seeing all the new projects. Not an amazing graph on my part in terms of we really want this to be cumulative. Okay. I'm going to see. I can actually suggest a title. If I say, here it is. Title, year, and then frame. This one says frame time. Okay, so the transition time, year. Frame time. Okay, I'm going to give this a shot. I don't think there's anything specific here. So if I say year, frame time, and there's more of the country. Okay, and I'm going to drop the FPS. Oh, I forgot a plus here. Okay. Year, frame time. I say frame time. Does it need to be something else? Oh, transition time. Oh, okay, right. Instead of transition states, I'm going to say transition time, year. Having a great time. Oh, that's right. I have infinite. Not is infinite year. That could be where we got a segfault before. I'm not sure. The graph takes longer than I'd like. But while I'm at it, I'm going to... This is a little hacky, but I'd like to quickly read up on the... what was it? Transition time. We have time and we have range. I wonder, yeah, there's no way to make it cumulative. That's good to know. Okay. Transition time. All right. Yeah, the story is when you have time, we can use transition time. Now this might work. Let's find out. It shows within a year. That's a little bit silly. Ah, look at that go, though. Look at it. It's everything except cumulative. We're getting pretty close. This is not close, but I think I can actually put a round in here, and that'll end up working. We'll find out if this is using glue, which I think it is. There's one more step. Now the thing is, this is not the proper way. Probably. I'm going to talk to Thomas later, and he's going to tell me this is really silly, but I'd like to make this graph cumulative. I'm going to use a trick. I'm going to say year is everywhere from 1980 to today. So I'm going to say time is 1980 to what is the maximum year. And not NA. I'm going to do it to 2017. And I'm actually going to cross it by time and then filter for year greater than or equal to time. This is a fast way to make any graph. Here it is. And then year would be the year it actually is released. The year it actually happens. So this is a really fast way to make any table cumulative. What you do is cross it by a new column, and then filter for only years that are after that column. That actually ends up duplicating every row that comes before a particular point. It's a trick I use a lot. There are other approaches to working with cumulative tables. This just happens to be one that I know off the top of my head without having to go look it up. No, don't worry, we're going to get rid of this one. bet I can say enter fade and it's going to look even cooler. I'm not going to do that right here, but I bet I can control it for the animations to pop up. Let's watch it animate. And nope. What happened? Where is it going? How did this happen? All right. Well, I sometimes get the comment on Twitter that says, these presentations are exciting even if it shows places that I make mistakes or need to look things up. Well, I get to now find out if those people mean it, because here I am trying to figure out how to properly make a animation and getting a bit lost. Well, it would have been nice to see all the things pop up, but this graph is not what I was going for in this case, though it is certainly evocative. All right, and let me see, time. Every one here should have been popped up multiple times. Like if I counted time, we should have had. There's your problem. There's a problem. Year is greater than or equal to time. Oh, wow. Okay, that's one start. Let's find out if this fixes it. I actually needed to say the year was before a particular year in time. Otherwise, this decreases as we go, and points are disappearing. Having said that, I don't see how you get to here from there. That was one mistake. It's probably not the only mistake that I made. Okay. See how this one looks. Oh, it's way better. Here we have wind spreading out over the world. Having said that, one thing I can see now is that where it's breaking is in between the years. Right now, it's interpolating points as moving. And that's how we're getting this thing spreading out as opposed to points appearing or disappearing. So that's because I think I'm using transitioning here, whereas I actually don't want to transition over time. I might just want... Oh, what does transition reveal? Keeps. Okay. I'm going to stay a minute longer and try this. One moment. Transition reveal by year. I'm going to remove these rows. That was probably what I wanted. But let's see. Quarter expression. Let's find out if the frame time still works. Nope. Transition reveal. The ID is the ID of the row. If I look at the examples, transition, the other transition, dimension between along, and the group aesthetic. All right, it's not. Oh, okay. So the here was the string. I realized I want to use frame along. Okay. So intermediate values. Let me see. It only keeps the old data for path and polygon layers. Okay. ID of the row, the group. All right, so the problem is we don't actually have groups in here. So I wouldn't want to keep so I don't know how to transition reveal with points instead of lines. I can wildly guess. I can say, what if I told it the year is the group, and we find out what happens. But this will be my last attempt. If it doesn't work, we'll close it out. But while this is rendering, just to point out, we've had some really interesting findings. We discover the spread where it's located. Wind turbines are located throughout the continental United States. We compared turbine size to turbine capacity in kilowatts, and we discovered a trend between them. We discovered that the typical capacity per turbine has largely increased over time, and we may or may not get an animation. Aha! Here it is. There we go. Here is our GG Animate code where we see turbines appear over time. 8, 9, and here's where they all really start appearing. To me, we're close here, but I'm realizing that there should be a lot more points appearing than there are. We're not seeing the points coming from like some of the later years. It's definitely not as crowded. So there's still a bug somewhere. I don't know the answer just to watch. Does it go all the way up to present date or to 2017? It does, and we don't have quite enough points. That's all right. In case bugs happen, and they're happening live because I haven't tried this before and haven't prepared with animation. But I hope you all enjoyed this tour of wind data where we looked at at all the things we looked at so far, like the comparing capacity to all the graphs that we've made in terms of it's not popping back up. Sometimes when that happens, you have to do a nope, I lost my graphs. That's all right. Where we looked at analyses by project, distribution by turbine model, and an animation of change over time. All right, so I hope you enjoyed watching me admit that I am not as familiar with the new GG Animate API as I would like, and I'll see you next time.